very happy to invite Alan Rothenberg to the stage and say a few words.
Hello, and thank you very much. I don't want to take away from the time for the actual meeting. I just wanted to say a few words about Eric Davidson and why it's appropriate for this meeting to have been organized in such a way as to coincide, give or take 6 weeks, with his, what would have been his 85th birthday. I think those of you who didn't know Eric, I'll try to say something about what he meant to those of us who did. He was a very unusual person. He was extremely thoughtful, extremely knowledgeable, extremely pugnacious in his way of putting forward his ideas and defending them against all comers. And the advantage of this was that his ideas were crystallized through his discourse in a way which made them extremely lucid, and they were a challenge to people who wanted to take a different point of view. It actually gave you something to deal with. You had to actually test your ideas against this structure, and it was a tremendous spur to clear thinking, I think, for many of us, whether we ended up agreeing with him or disagreeing with him on a certain point. And I think it was a great legacy to us that many of us do remember the intensity with which he would marshal whole structures of information and arguments and inferences to try to make a point. And it's something that perhaps in a less pugnacious but equally intense way we would like to continue in our own work. Eric came of age at a time when developmental biology was dominated by classical embryology, and it was in the dawn of the DNA age. And he was in an unusual position in the field of molecular developmental biology because he saw himself as a revolutionary at the time by forcing developmental biology to become molecular and to take into account new insights into gene regulation as the basis for actually creating organized biological complexity out of simplicity. But because he had been brought up when he was, and because he wanted to know the opponent, he ended up being one of the most deeply learned scientists that any of us knew in later decades, who, in the actual literature and evidence of the earlier classical embryology. And so, in a funny way, his position shifted from being the one exponent of molecular mechanisms to a largely classical audience, to, in later times, being the one person who actually knew the complexity of classical embryology, an enormous range of different organisms spanning large amounts of the phylogenetic tree of multicellular life. And this gave him a perspective. It was very heady to talk with him because you had a feeling that you could see perspective on biological complexity that you missed when you were talking with someone about their own specialized model system. Eric loved meeting Uta, who had been organizing conferences on the history and philosophy of sciences, because their interests intersected in a number of ways. Eric was fascinated by history and read deeply in history throughout his lifetime. And Uta's thought about the history of science specifically in the 20th century, above all, connected with people that Eric had actually known, or he had known their students. And so this was an initial point of great interaction. But as they continued their discussions over the years, I was just struck by the sense in which their dialogue was extremely productive, especially for Eric, and he felt that he was really learning a huge amount based on the historical and philosophical challenges that Uta was throwing down. And he became more and more interested in epistemology in science as a subject of inquiry in itself, and became more and more clear in his mind about the crystallization of this. Now, the theme of this conference, Plasticity and Constancy, in a sense, would have been the culmination of a lot that Eric had thought about. At the very beginning of his independent career in the late 1960s, he and Roy Britton published a very influential paper in Science postulating the first embryonic, in the metaphorical sense, version of a gene regulatory network explanation for the complexity of multicellular organisms based on a single genome being expressed in a regulated way, in a different way in different cell types. And this was this kind of vision of how you control complexity from a single genome was really the basis of his entire life's work. But at the same time, he became more and more aware that the architecture of the network connections themselves could have meaning. It wasn't simply that there might be a regulator somewhere that would turn this gene on somewhere. It was that actually the architecture of the connections, their recursiveness, their degree of feed-forward reinforcement, their degree of operating with indirect, potentially incoherent linkages, that this could actually be an important feature that would control whether or not a gene network would be hard to break or whether it would be easy to break. Now, and so he built this, he returned with this, especially in work done with Doug Irwin, into a theory about the long-term conservation of body plans since the Cambrian explosion, which I mentioned. I think that the one thing that Eric hated in biology is going to come out in this conference, which is that he really hated the idea of chromatin level constraint on gene expression change or on any kind of biological change. And so he argued always for control at the level of transacting factors, finding their sites in the DNA unencumbered. And I think that his resistance to the idea that chromatin state could be a memory mechanism in organisms. He could get away with this because he was really studying the first 30 hours of development in one organism. Many of us study events that occur long after those first 30 hours, and we need chromatin level mechanisms to account for genetic memory, for gene expression memory. But the beauty of arguing with Eric, as I was saying at the beginning, was that he would always force you to put your best argument forward. You had to really marshal your arguments and your data, and you had to be rigorous, clear, and logical in the way you presented it. And so whether it's to the parts of his models that have stood the test of time or those that have had to be modified as things that appeared to be assumable have turned out not to be assumable, I think all of us who have worked closely with him have been influenced by him, and many of us would say it's been an enormously fertile and gratifying association. And for those of us who liked him personally, he's a really tough act to follow, and we miss him very much. So to thank you so much for organizing this meeting and making it be, to some extent, a memorial to Eric. And I'd love to, I don't want to stop the science any longer, but thank you.